How do astronomers gather information about space? We're going to do 3 reads and 3 questions. Today, I can identify how different wavelengths of the electromagnetic spectrum, such as visible light and radio waves, are used to gain information about components in the universe.
What do all these activities have in common? Each of them use waves from the electromagnetic spectrum. The electromagnetic spectrum is composed of EM waves. These are waves that are created as a result of vibrations between an electric field and a magnetic field. In other words, EM waves are composed of oscillating magnetic and electric fields. This is why they are called electromagnetic waves. The electric field and the magnetic field of an electromagnetic wave are perpendicular or right angles to each other, and they're also perpendicular to the direction or propagation of the wave. The electromagnetic spectrum is ordered by frequency, which is the number of wavelengths that pass a fixed point per second. Frequency is measured in hertz, and the spectrum has a very wide range from 300 kilohertz to an incredibly small 3 times 10 to the 21st power hertz. An electromagnetic wave can travel through anything like air, solid material, or even vacuum. It does not need a medium to propagate or travel from one place to another. Electromagnetic waves can even travel through the vacuum of outer space. Let's take a look at the electromagnetic spectrum. Radio waves have a very low frequency, and they have a wavelength roughly the size of a soccer field. Moving to the right are microwaves, and they have wavelengths roughly the size of a baseball. In the middle is visible light, with a wavelength the size of bacteria. Visible light can be subdivided by color, with red having the lowest frequency and blue having the highest frequency. Now, at this point, the wavelengths are very, very small. X-rays are slightly larger than a water molecule, and radioactive sources, such as gamma rays, are the size of atoms. The electromagnetic spectrum is used in everyday life, from listening to music to visible light to microwave ovens to even looking inside our bodies. If you'd like to know more about the electromagnetic spectrum, this playlist will help. And as always, thanks for watching, and Moo Moo Math uploads a new math. What are all these activities?
Okay, so we're going to do our read now. We're going to have 3 reads, and it's the same reading, but 3 different questions. So as I read the text, I want you to think, what is the text about? Okay, how do astronomers gather information about space? So, what is the text about? You're going to tell me this text was about, and think about it. Most of the information we have about the universe comes from radiation. Objects in the universe, such as stars and galaxies, emit radiation. Radiation travels in the form of waves. Different kinds of radiation have different wavelengths and energy. We cannot see most of the radiation, but telescopes are used to collect the radiation for astronomers to study. The entire collection of different kinds of radiation is called the electromagnetic spectrum. The electromagnetic spectrum is a continuum of waves divided into regions based on their wavelengths. At one end of the spectrum are radio waves, which allow you to listen to your favorite radio station. In the central portion is the only part of the spectrum you can see with your eye, the visible region. Most of the region comes from the sun. When light is passed through a prism, it bends and separates into different wavelengths or colors of the rainbow. Spectroscopy is the study of the spectrum. A spectroscope is an instrument used to separate light into its component wavelengths so they can be studied. The patterns of wavelengths and colors is called a spectrum. By obtaining and analyzing the spectrum from distant objects, astronomers can determine the object's temperature, density, direction of motion, and composition. Each element composing a star has a unique spectrum, just like a fingerprint. Astronomers use spectral patterns from stars and other objects to determine what elements compose the object. So, this text was about, think about that. Okay, the reading continues to be the same, but now I want you to think, what is something I already knew about this reading? The author assumed I knew. What do you think the author assumed you knew? What did you learn from the text? So think about that. Now I understand. Give me 5 summarization. The first fact from the reading is the second, third, fourth, and fifth fact are. So you're going to put that there. So go back to the reading, and each piece is the same, and list a fact. Okay, I want 5 facts. So the first fact, second, third, fourth, and fifth fact. And that's up to you. It's a very factual reading piece. So the facts that you choose are up to you. For our exit question, we're going to look at a star connection question on the electromagnetic spectrum. The diagram of the electromagnetic spectrum is shown below. Earth's atmosphere blocks short wavelengths of the electromagnetic spectrum. Which telescope must be placed in orbit around Earth in order to observe short wavelength radiation? So if these waves from crest to crest are your shortest, you understand that these are gamma rays. So scientists would need gamma ray telescopes in order to observe these wavelengths. And then, of course, over here, your radio waves are your longer wavelengths. I hope you liked reading about the electromagnetic spectrum today.